We'll start off this worksheet on number 3. What is the greatest common factor of 72 and 40? How would you figure that out if you just didn't know? You could go through them. Does 2 go into both? Yeah, how do you tell? They're even. Does 3 go into both? How do you tell? Add the digits. 7 plus 2 is 9. Does 3 go into 72? Yes. 4 plus 0 is 4. Is 4 divisible by 3? No, so 3 didn't work. Well, if 3 doesn't work, what other numbers won't work? 6, 9, 12, 15. Any multiple of 3 is not going to work. So we know that 2 works. What about 4? 4 does. What about 8? 8 does. What about, we already know 9 doesn't work. What about 10? 10 doesn't work, and 10 times 10 is 100, so we don't need to go any higher because we're already big enough. So number 3 would be 8. What about 4? 9. Y. Correct. Okay. Number 5. What's the biggest number that goes into all of those? 7, n raised to the 7th. Does anybody not understand why? Well, if we were to break these down, 42 would be 2 times 3 times 7 times n. And 35 is going to be 35 n 8 times. And then 21 with 9 n's. And 49 with 11 n's. Now we start matching them. Match this one, and this one, and that one, and that one. Match those, match those, match those, match those. And all of those have matches, and these all have leftovers. So you look for the biggest number that they all have. So there's a 7, an 8, a 9, and an 11. So what is the biggest number that they share? 7. So this would be 7n to the 7th. What if that 49 was n to the 2nd? Then it would be 2. What if that 49 didn't have an n? Then the answer is just 7, and there are no n's that they share. Okay? So the first question asks, in your own words, explain how to find the greatest common factor. However you do it is fine. So write down your favorite method for finding the greatest common factor. Number 2 asks, oh, sorry, you guys aren't done. I'll wait. Number 2 is asking, what does it mean to factor a polynomial? And there are 2 ways to factor a polynomial. The first way is using the greatest common factor. You look and see, do they share anything? And you always do that first. Once you figure that out, the second way to factor is using the box. Or whatever method you use that's equivalent to the box. Okay. Take a look at 6. The instructions say, factor out the greatest common factor. And if the leading coefficient is negative, factor out a negative. If you cannot factor anything, you write prime. Can we pull anything out of number 6? 7 and x. So 7x, what's left? X minus 2. Good. What about number 7? But if the first coefficient is negative, then we pull out negative 8. The reason is the box does not work if the first number is negative. So if your first coefficient is negative, factor out a negative, and that will turn it positive. So on 7, we get negative 8. What's left? A. Can we take a negative 8 out of a positive 16? Well, a positive is really just two negatives. So a positive 16 is kind of like negative 16. If I take one of those out and an 8, I have a negative and a 2 left over. So whenever you pull out a negative, that will change every sign that follows. Okay? Take a look at, let's do number 12. What can I pull out of 12? 4R. So 4R. What's left? 2R squared minus 9R. Well, if I had a 4R and I take out everything, what's left? Nothing, but nothing in multiplication is actually a 1, right? So A plus what equals A? Is there a number that I can add to A without changing it? 0. A times 1 equals A. Oops. A times what equals A? 1. So there are two different nothings in mathematics, and the nothings are the numbers that don't do anything. When we're talking about addition, the nothing number is 0. It's called the identity. It's the number that doesn't do any work. When we talk about multiplication, the do-nothing number is 1. Anything times 1 is itself. So if I pull out everything, I have nothing left, but nothing, according to multiplication, is a 1. Okay? Let's look at... Oh, which one was it? Number 20. What's the greatest common factor in 20? Do we have any b's in common? No. Do we have any factors in common? What are the factors of 29? 29 is prime. So technically this is prime, but there's a problem with leaving it like this. What is the leading coefficient? Negative. And it said if the leading coefficient is negative, pull it out. Can we pull out a negative and nothing else? Is it okay to write negative parenthesis? Yeah, that's fine. Because all you're really doing is pulling out a negative 1. And is pulling out a 1 going to change anything? No. So that would be 36b6 minus 24b to the third minus 12b minus 29. All right. And the last one I want to do is 22. Well, let's look at 19. What would you pull out of 19? 6 goes into all of them. Anything bigger? Does 12 go into all of them? Yes? Okay, anything bigger? So it's not just a 12 though. Negative 12, and what else? How many x's? X to the 6th. How many y's? Y to the 2nd. So I'd be left with 2 y to the 3rd. plus 3y squared minus 5, and that's it. Everybody understand that? Okay, now 22. 22 is a little strange. Does this term and this term have anything in common? They both have a v plus 2. Can I pull a v plus 2 out? Well, what if it was just a big A? Could I pull it out? Yeah, it's just some number. We don't happen to know what it is. So if I pull out a v plus 2, so I cross this off and I cross this off, what's left? 4u plus 3. Okay, put your pencils down for a second. We're going to turn the page and do the next side, but we have to go back to how the box works. If I had x plus 1 times x minus 4, how big would the box be? 2 by 2, right? What if I added an x plus 3 on here? What is that going to do to the box? Well, these put together are x squared minus 3x minus 4 times x plus 3. So how big would this box be? 3 by 2. Okay? Now, there is a way to end up with, so this ends up being x to the third, I don't know, plus 4x squared minus 6x minus 12. There is a way to take this equation and factor it and get back to this. But it's really hard to do. It's so hard to do, we've come up with easier ways to figure it out. So we're not going to do it. All right? But sometimes you can cheat. If we had x squared minus 4 and x plus 1, how big would that box be? It's still a 3 by 2. How come? I have an x squared term, and really there's a 0x hiding inside that. Could I multiply it in a 2 by 2 box anyway? I could, but would my diagonals line up? No. But you could create a 2 by 2 box that works. And because of that, sometimes when you see an x to the third equation, you can use a 2 by 2 box to factor it. If it's a 3 by 2 box, then there's an easier way to do it, so we're not going to try. But today we're going to practice cheating and factoring x to the third polynomials into 2 by 2 boxes. It doesn't work very often, but every once in a while it does work. So turn the page. Look at number 24. First of all, we have to look to see if there's a common factor. Is there anything we can pull out? No. So I'm going to build a 2 by 2 box, and I'm just going to put the things in order, even though the diagonals don't line up. So I'm going to put 2h to the third minus 5h squared plus 8h minus 20. Okay. Do my diagonals match? No. On that second diagonal, I have an h and an h squared. Okay? But we're just going to try it and see if it factors. So we look at the top row. What does the top row share? H squared. If this is an h squared, what goes on top? 2h. Does anybody not understand why? No? So, do you get why this is h squared? Well, if you take 2h to the third and you divide it by h squared, what's left? Well, if I pull out 2 h's from this, I'm left with a 2 and an h, and that goes here. If I pull an h squared out of this, what's left? The h's are gone, and I'm left with negative 5. Okay? So if I pull a 2h out of this box, what's left? A 4. And now, here's how we test to see if it's prime. Is 4 times negative 5 negative 20? Yes. So this worked, and my factors are 2h minus 5 and h squared plus 4. So this one worked. And in fact, every one on this worksheet is going to work. But if you were to do a random x to the third, it wouldn't work. So if I just did x to the third minus 5x squared plus 2x plus 10. So if I just make that up, chances are it's not going to work. So you don't need to write this down, just watch. These share an x squared. If I pull out an x squared, I'm left with an x. If I pull out an x squared, I'm left with a negative 5. If I pull out an x, I'm left with a 2. Oh my goodness. I almost did it. Is 2 times negative 5 positive 10? No. So this would be kind of considered prime. But if that was a negative, then it would have worked. Okay? So everything on this page is going to work, but just know that most of the time it doesn't. Okay? All right. Look at number 27. Can I factor anything out? No. So I build the box, and I get 24p to the third minus 64p squared minus 3p plus 8. What does the top row share? 2. Anything bigger? 6 does not go into 64. 8 is the biggest. How many p's? There are 5 total, but how many do they share? 2. So 8p squared. If I take an 8p squared out of this, what's left? 3p. If I take an 8p squared out of this, what's left? Negative 8. If I take a 3p out of this, what's left? Negative 1. Is negative 1 times negative 8, 8? Yes, so this one works. Yeah. If you multiply those two and they don't match, then it doesn't factor. It would be considered prime. So my answer is 3p minus 8 times 8p squared minus 1. Those are the two factors. All right. Let's do 30. Can I pull anything out? Does 4 go into 30? No. So 2 is the biggest. Can I pull out any p's? Nope. So we pull out a 2, and I'm left with 6p squared plus 8p, third, 8p squared minus 15p minus 20. So now I build the box. I just fill the box in, 6p squared plus 8p, that's third, that's squared, minus 15p minus 20. What is shared in the top row? 2p squared, good. If I take out a 2p squared in this first box, what's left? 3p. So that goes on top. If I take a 2p squared out of this box, what's left? 4. So now, if I take a 3p out of this box, what's left? Negative 5. Is negative 5 times 4 negative 20? Yes, so now I write out the factors. 2p squared minus 5 times 3p plus 4. That's the answer, right? No, what did I miss, Reese? I forgot the 2. In the beginning, I pulled out a 2. Don't forget it. It goes out front. Okay. Look at 32. 32 is written backwards, and it has Q's and R's in it. Let's just try it and see if it works. You could reorder it if you wanted, but let's just try it as is. Can I pull anything out? Nope. Let's build the box. 21, negative 7Q, 3R, and negative QR. What does the top row share? 7. If I pull out a 7 from 21, what's left? 3. If I pull a 7 out of negative 7Q, what's left? Negative 1Q, or just negative Q. If I take a 3 out of 3R, what's left? R. Is R times negative Q negative QR? Yeah, so it worked. So 3 minus Q is one factor, and 7 plus R is the other. Should we do one of the hard ones? Let's do number 40. What's the biggest number that goes into all of those? Does 12 go into 105? 105 is not even, so it can't be an even number. It has to be an odd number. 3 does. So if 3 works, we want to test 6, but 6 is even, so 6 can't go into 105, so let's try 9. Does 9 go into 12? No, so 3 would be the biggest. So 3 goes into 105 35 times. So I pull out a 3. Can I pull out any variables? Y to the third, any C's or K's? No. So 3y to the third. What's left? 35c plus, what's 42 divided by 3? 14. Any y's left? Just a k. Plus 5. Any y's left? Or not 5, 10. 10y. Any c's left? C. Plus 4y k. All right, let's put this in the box. 35c, 14k, 10yc, and 4yk. What does the top row share? A 7. If I take a 7 out of 35c, what's left? 5c. If I take a 7 out of this one, 2k. If I take a 5c out of that one, 2y, and now we check, is 2y times 2k 4yk? Yes. And don't forget this 3y to the third. So my factors are 3y to the third times 5c plus 2k times 7 plus 2y. That's it. All right, you have about 18 minutes to work on this. You should be able to get most of it done and then not have much homework over the long weekend. Have fun.